Okay, welcome to lesson 3. So we're still talking about data summarization, and this time we're going to focus on measuring the center. So what we mean by center is when we have a data set and we're trying to estimate what a typical value in a data set is. The two types of center that we tend to describe are the mean and the median. So a lot of times the mean or the median is going to be used to describe a typical value. Okay, so here we're going to go ahead and define what we mean by mean and median. First, we're going to introduce the population versions and then the sample versions. So the population mean, we use the Greek letter mu. Here we have mu sub x, but it's the Greek letter mu. It's not an M, it's just a Greek letter. And in order to get this is taking the average over all observations in a population. So if you're able to get all the observations, this symbol here means sum, so add them all together, and then divide by capital N. It's the size of the population. Population median, so it's denoted by mu with a tilde on top, and it's the 50th percentile. So if you were to line up all of your observations in ascending order, so from smallest to biggest, half of the observations are going to be smaller than your median, half will be larger than your median. Then you have your sample mean. So this is if I were to go ahead and have, n, so lowercase n observations, I'm going to add all of them together and then divide by little n, so the number in the sample. We use x bar. So notice these two we use Greek letters for. We have mu and we have mu tilde. Here, x bar, we aren't using a Greek letter. Similarly with the sample median, we are not going to use a Greek letter either. So we're going to use x tilde or the letter M. Either one is used pretty commonly. So this will be that situation. You have a sample data set. You go ahead, you put all of the observations in order from smallest to largest, and the observation that's smack in the middle, such that half are below and half are above, that's going to be our median. So for example here, we want to calculate the sample median, and we have the 50 states data. So we're looking at percent that stayed in their state for their first year of college. So the first thing we want to do is order them from smallest to largest. One thing that's neat is the stem plot or the stem and leaf plot does exactly that. So step 2, find the middle observation. This can be a little bit trickier, but it's going to be doable, and we'll do that. So here's some kind of rules. So if it's odd, the median will be a single value. If you have a sample size that is even, it's going to be the average of the middle two observations. For me, it's easiest to think of folding the data set in half. So example, if I have a data set, I'm making this up, 1, 2, 3, 4, 5. And I want to fold it in half. It's only on one, so my median there is 3. If I have a data set that has an even number, so 4, 8, 12, 16, so there's even. If I want to fold it in half, I need to average 8 and 12, so now my median is going to be 10. That kind of idea. So trickier here when you have 50. So I'm going to have 50 here. If I want to fold it in half, there's going to be 25 on each side. So this means I'm going to have the 25th and the 26th here. I want to average the 25th and 26th observations. And absolutely feel free to plug it into here. N is 50, so n divided by 2 is is 25, n plus 2 divided by 2, that's going to be 26. So in order to find them here, I am going to take note here. I have 1 here, 1, I have 3, I have 7, 4, 8, I have 11. Okay. So if I want the 25th and 26th observations, I have to figure out where they are. So this is the first observation. This is the second. Here we have I'm just adding 2 plus 3, the 5th. I have the 12th observation here. I have the 23rd. So I'm getting closer. So this is my 24th, 25th, and 26th. So I want to average 80 plus 80 over 2. That's just going to be 80. That one's really easy. Averaging a number with itself will always just be that number. So my median is going to be 80%. Don't want to drop off the units there. And here, this is cool. If you have the slides downloaded, you can click on this button here and it'll take you to a video that shows you how to go ahead, plug this in, and calculate this in on a TI-84. So now we want to use these data below. So we have, these are 20 commute times from 20 randomly selected New Yorkers, and we want to calculate the mean and median for these folks. So finding the mean, it's going to require that you take all 20 of these observations, add them up, and divide by 20. So when I do that, I add all of these together, I get 625, divide that by 20, and my mean, so my sample mean here is going to be 31.25 minutes. And for the median, I believe I have my own slide here. So I'm going to, it's very, very important to have a note of how many there should be. So if I wanted to fold 20 in half, I need to get 10 on each side. So 5, 10. So I'm going to argue it's here, but double check. You should have, yeah. So I have 10 on both sides, right? That's the idea. I have folded it neatly in half. That means I need to take an average of these two middle ones because I have an even number. So my median is going to equal 20 plus 25 divided by 2. And that should just be 22.5 minutes. So my sample median here is 22.5 minutes. So one thing that's important to compare how the mean and median will work. If you have a fairly symmetric distribution, so it can be exactly symmetric or, roughly symmetric. The idea is if I drew a line down the middle, it looks roughly the same on both sides. The mean and the median are going to be really close to one another. They're going to be really similar. You could really use either one. It's not going to make a big difference. Where it does make a big difference is if we have skewed data or we have extreme outliers. So like here in this example, this is skewed left. It pulls the mean closer to that left tail. So whatever tail you have, it's going to pull the mean closer to that tail. One way to think about it, salaries at a company are almost always skewed because you have a lot of folks making lower wages and then you have a few folks up top making really high wages. The idea is, like, take Amazon for example, you're not going to want to have a sample with Bezos in it because he makes so much more than everybody else, he will pull the mean way over in his direction. So you're going to want to use median if you have a very skewed distribution or if you have extreme outliers. And in general, when the sample sizes are large, it doesn't make as big of a difference, but definitely keep an eye. Do you have very skewed data or do you have some extreme outliers? It's worth at least making a note of in your write-up. So just to compare, we have, this is our student staying in state data. You can see it's skewed left just a little bit there. And if you look, this purple line here, that's our median. And this dotted blue line is our mean. It's skewed left. The mean is pulled a little to the left. They aren't going to be equal to each other. So our median's 80%, our mean is a little lower, it's 76%. So next, we're going to be measuring variability. We're going to talk about standard deviation and IQR, and we'll see you there.